Okay, we're going to discuss the Pythagorean Theorem, which basically says when you have a right triangle with side lengths A, B, and C, in which A and B are the shorter sides and C is the longest side, A squared plus B squared equals C squared. And though it can be really useful when you're trying to find the lengths of what is A or what is B or what is C, the main thing that made the Pythagorean Theorem so famous as one of the most famous in all of geometry is not just because of its use, but more of how many people tried to prove the theorem. But in this video, we will discuss a proof made by Garfield. No, not that Garfield, this Garfield, who was the President of the United States, until unfortunately he was assassinated. While Garfield was still at the House of Representatives, just 2 years before he became President of America, he had formed a proof of the Pythagorean Theorem. And in the rest of the video, we will get into that proof. Say we have a right triangle with side lengths A, B, and C. And now say that we were to rotate another right triangle with the same side lengths just above the first triangle, so that there is a 90 degrees angle between the two C side lengths. If you were to draw a line from this vertex to this vertex, we would get a trapezoid. And to find the area of this trapezoid, we can use two different methods. One method is to find the area of the entire trapezoid just by using the trapezoidal area formula. But another method is to find the area of each individual triangle and sum them all up to find the total area of the trapezoid. Let's first start with the first method. To find the area of a trapezoid, you'll multiply the height, which in this case is a plus b, times the average of the two bases. So we have a plus b times a plus b over 2. But in the other method, you find the area of the first triangle, which is a times b over 2, then of the second triangle, which has the exact same area, and finally of the third triangle, which has area c squared over 2. So let's just study this equation. If we were to multiply both sides by 2, we would get a plus b times a plus b equals ab plus ab plus c squared. If we were to add these two ab's, we would get a plus b times a plus b equals 2 times ab plus c squared. And now if we were to expand this equation, we would get a squared plus 2ab plus b squared equals 2ab plus c squared. Is there anything we can subtract from both sides of the equation? There sure is. We can subtract 2ab's from both sides of the equation to get a squared plus b squared equals c squared, or the Pythagorean Theorem.